Hello and welcome to the third webinar of the Semados Campus special webinar series for professionals. My name is Marcio Garcia dos Santos and I am part of the education and research team of BEGO Implant Systems. I will be the moderator of today's session. First of all, I hope you and your family are all in good health. Before introduction of our speaker today, I would like to thank Mrs. Angelica Jacob from BEGO Implant Systems Market Department for the organization of the session, and say that we have almost 450 enrollments for the lecture today, and we thank you for your interest. The topic today will be CAD/CAM, individual prosthetics, and the speaker will be my friend, Mr. Stefan Kautz. Mr. Stefan Kautz is a dental technician. He finished his studies in Hanover in 1992, opened his own dental lab for an exclusive circle of sophisticated dentists in 1996, specialized in the field of all ceramics, implant technology, combined dentures. Back in 2001, he began to integrate a CAD/CAM system into his work processes, which opened the way to new all-ceramic materials. In particular, he developed his skills in the field of implant prosthetics to achieve even better aesthetic results for his patients, making him a specialist and one of the pioneers in the field of individual gingival forming. In 2018, he joined the BEGO team as a trainer and course instructor. Thanks, Stefan, for conducting the session today. As always, at the end of the lecture, we will have the question and answer session. And as most of you know, you can place your questions in the question box during the whole presentation. I wish us all a nice time, and I give you the word, Stefan.
Did you hear me already?
Yes, we hear you.
Because I got a message that my micro is right now on. Thank you, Marcio, for the friendly introduction of my person. And welcome to all the participants to my webinar. So everything is set, so we can start directly. So in the end of this session, there is enough time to do a questioning and answer. And Marcio will be so friendly and moderate this. So now I will switch off my camera for my presentation, and in the end I will come back and then we can discuss open questions. So enjoy your time, have fun. CAD/CAM individual prosthetics with 3Shape and Exocad. So I will talk today about the digital workflow, how we from the BEGO team live and see the digital workflow. Then I will go over to show you just the procedure, how we come from the intraoral scan to an implant restoration, with the focus on using the material libraries and the focus on the model printing. Then next we will come to the download of the material libraries that we have on our website. Next point is the integration of the material libraries into 3Shape. The next point is the integration of the material libraries into Exocad, and then I will show you some facts to the DIM analog, and at the end I will come to a point that I'm especially interested in is the gingiva management, because if you do not know how to do your gingiva management manually, it will be also hard to transmit it into the CAD system or into your CAD work. So I will give you some yeah, I will show you some topics about how to open the gingiva and which aspects are really interesting in it. So let's start with the digital workflow and how we from BEGO think and live the digital workflow. Okay, we are starting with the initial situation. Probably we did a pre-planning, a dental technique pre-planning setup for example, and then we send the patient to the CT or the CBCT to do our implant planning. And based on this data that we generated in the CT and CBCT, we can start our implant planning. And based on this data, we can produce a surgical guide. But also based on this data, we are already able to produce a provisional crown that is which still has to be manipulated in the practice, but we can send already with the guide also an printed lab provisory. Then we come to the surgery, so the insertion of the implants. And the next point, we have to do a digital impression taking. Directly still in the fresh inserted implants. Even if the wound is still open, you can do your intraoral scan to generate data for the permanent dental or implant restoration. Then we go over to manufacturing or to produce CAD based a digital model, and this will be supported by the 3Shape software, Exocad software, and also the dental wings software. And based on this data, we will generate our complete restoration or restoration parts. So this is the way how we think the digital workflow. But today in my lesson, I will talk about the workflow from the intraoral scan, about the intraoral scan import into the CAD. So what's happening there? Then we have to work with the imported file in our design, and at the end we will receive our or we will be able to print our model and print or mill our crown or abutment construction. So everything is based on the intraoral scan. The intraoral scan is almost similar to the extraoral scan, to the lab scan. The output, the data file is always the same. So starting with the digital impression, and when I'm talking now about the intraoral scan, it also includes the extraoral scan, because what's happening is always the same. We are just generating a 3D surface model and generate with this an STL file, and an STL file is always the base of a machinable language. So we have to use our cut positioner. We can use them for intra and extraoral scans, and then we generate our 3D surface, our FTL file, and next we have to do a data transfer. So we transfer our STL files for further processing in the CAD. Okay, let's come to the scan bodies. We have the scan bodies for intra as well for extraoral scanning. Very important is that on each scan body is in the digital version always a big amount of informations that we need to produce in the CAD. So always in the CAD we have this information stored, and we can choose our desired implant or our desired implant construction. And for that we have to use specific scan bodies, physical scan bodies that are also available in a digital way with the additional informations. So for you, important to know is that the platform switch implants, the SC, SCX, RS, RX, and RI with platform switch have diameter specific scan bodies. So we have scan bodies from 3.0 up to 5.5. And on each scan body in the digital way is a big amount of data that we have to use in our CAD. For the S implant, it's a little bit different. So the S implant with the platform match, we have only one scan body for all all diameters from 3.25 up to 5.5, and also on the multi plus on abutment on implant level, we have one body for all diameters from 3.25 up to 4.5. But this is only to the scan bodies. I think everybody knows them. Important is to say to the scan bodies, so if you're going to work with BEGO components, you need BEGO scan bodies. If you are going to work with Zimmer components, you need Zimmer scan bodies. So please stay in your system, otherwise you can't match the situations. So now we already generated a 3D surface with the intraoral scan, an STL file. We have to send this to our CAD. So we have to import the intraoral scan into the CAD. And important or interesting is that I have here three pictures of scanners: extraoral scanner, intraoral scanner. All the scanners are doing the same. They have the same file output. They are creating an STL. STL is the base. 3Shape has got some additional informations. The 3Shape file is called DME, but the base of a DME is always an STL. So you will always find in other file formats, the basic information will be the STL. And then, for example, you have additional information about the color information and shade information, something like that. But the basic is always the same. If you're using an intraoral scan or an extraoral scan, there is no difference between this. This is a thing that you should keep in mind. So with the intraoral scan, we are generating an STL. So the STL describes the surface of a 3D object by using triangular facets. You see here, these are all small triangles, which set a 3D body when they are networked. This is the same file, is also an STL with a higher density. So here was the intensity of scans a little bit larger, and this one is a really high resolution, so a high density of small triangles, and this will produce raw surfaces, and this will produce smooth surfaces. So the name STL is standing for Standard Triangulation Language or Standard Tessellation Language. Both names are right. As you see here, here is an intraoral scan, which is zoomed, and here you can see the net of the triangles. This is the same, it's also an STL, but here's an additional information so that polishes and closes the surface, but the basic is the same. And here you already see this is the intraoral scan with our position markers or our scan bodies. On the next picture, you can see our STL files. This is a regular interdental scan, intraoral scan. All the scans start with one basic scan, where you scan all the T's and all the situation, but without the markers. This is an extraoral scan, and here we go in the same way. The first scan automatically produces this kind of picture, and the next scan will be done with our position markers, and in the end, these pictures will be matched together to get one picture. And on this one picture, we have all this information about the scan markers. We have parts like this, which we cannot match. So we have to cut our data files. That makes the matching process a little bit easier. So in the end, a finished scan should be matched with both scans together, and I will come later on to this. So now we imported our scan and we turn over to the design so that we can start our design. Our CAD system needs some more informations. So here we have, I will just stop it for a second. Technical problem. Okay. So our CAD system needs informations because when we did our scan, we have only a surface, and in the surface you can see a silhouette of our scan body. But the scan body that you see in the intraoral scan or in the extraoral scan is without any function. So I show you here the data file content. This is only one file in our libraries. This is, for example, a 4.1 a platform switch implant, and this is the 4.1 scan flag. And in this data file, we have the information about the placeholder for the DIM analog. So we have the information. This is the placeholder for the DIM analog. This is the tie base. You can see the screw. It will start again. Just 1 second. So we have the placeholder for the crown. It will show up really soon. So this is the placeholder for the crown. This is the implant. This is the information about the DIM analog with the placeholder. So we have placeholder DIM analog, placeholder crown, DIM analog, scan post, implant, tie base, and screw. All these informations are inside one data file. So these data files have to be implemented, stored in our CAD system. And so you will find, when you are starting your construction, you will find the information for your implant system For Exocad, you will find it available from the matching process. 3Shape, it will show up a little bit earlier. So for 3Shape, you will find the implant libraries already from the beginning at the order form. So you're starting your job order, choosing your tools, then you're choosing your construction, for example, abutment, and herein you can find all the information. You can find your desired implant, your desired construction supplies that you can choose. So just to come back to the STLs, what you see here in the first scenario, this is an only ordinary imported intraoral scan, nothing else. And you see, we have here, it's looking like a little bit camouflage. We have here these two models already matched together. I told you when we do a scan, we first scan the jaw situation, and next we got the request, please insert your scan bodies, and then we do the second scan. And this, what you see here on this picture, are the first scans matched and imported into my CAD system. So I'm already in Exocad. It behaves in 3Shape in a similar way. So I do my demonstration here in Exocad. So this is just an ordinary imported intraoral scan. We have here our marker, and you see the first scan was gray, and the second scan is here shown in green. And that is the reason why you can't see here any gray color inside the scan body, because for the second scan you have to screw it inside the mouse. On the second picture, now we are placing, so we are choosing our desired implant system, and now the system asked on which place you want to place your scan body. So I just do one click here in my green silhouette, and then it will be rawly placed. The golden scan body will be rawly placed inside my green silhouette, and then I have to click best match or best match fitting. That means that the golden scan body, this is the scan body from the material library. This is the scan body that we can find in our system, that we will import in our system just to choose it. This we will match exactly into this scan. So what you have to keep in mind is, in this scan, this is just an empty surface, and into this empty surface I'm matching my material library directly. And here you can see it's still both scans joining together. But if I would start now producing or designing a crown, it would be a big problem, because this massive part would disturb me. So that is the reason why, after this positioning, the second scan with this silhouette will be switched off. That's the reason why we can see this here gray. In this situation, we are in the crown design. Here I'm in the crown design, so I can if I want to, I can show my screw channel, I can show my implant components, even the implant. Yeah. Here I am in the crown design, and I'm designing my crown. And at the end, when I finished my crown design, the system will ask me, do you want to print a model? Because we did an intraoral scan and we do not have a model, but we need a model to complete the case. So, and then I confirm with yes, and then I come into this situation, and here you can see This is also, the model creator. I'm in the model creator, and here I have already the information about the placeholder for the DIM analog. So these are finished models, 2 different examples. This is a solid model, and here you can see inside the solid model the placeholder geometry. This is the same case, but I choose a different way to produce a model. So I choose here in my libraries the base plate from Baumann. This is a base plate to do separating or die or saw models. And this, here you can see again the placeholder. And this is the bottom side of the model. And here you can see the channel for the DIM analog, and here you can screw your DIM analog. So this is the way, or these are the facts from the intraoral scan to the restoration. But I forgot one important thing. We have to transmit our constructed STLs to our CAM, to our computer-aided manufacturing. I think everybody knows about abutment or crown milling, so I don't have pictures about that. The only interesting thing for me here is the 3D model printing. And so the milling machines are milling already, and I'm sending now my STL to my 3D printer. And for that, I need specific model resins. For example, we have from BEGO the BEGO Vaseo wax model, specific model material for model printing. And after the printing, the analogs should fit perfect and stable in the model. And I say should because after printing we receive this. So we have here two different models. One with a single crown. This is a model for multi units, and we created this placeholder in the right position in our model. So, but is it fitting? Is it fitting that well? In 3Shape, we have a solution that we can adjust the offset of these placeholders. In Exocad, there's a big problem because there is no possibility to adjust until the versions from 2020. So in this year, I'm not sure if they have it already, but in this year they told me they will launch the possibility to adjust the offset. So when I'm working with a standard offset and I'm inserting my DIM analog, it's not really stable in the model. So I can adjust it in 3Shape. Once I have adjusted it, it's fitting perfect. But I have the problem with Exocad. I cannot adjust it. And so that was the reason why we had been thinking about what can we do to get a perfect fit inside my model, because we get different results from different printers, make different results. And so we found a solution. Our solution is a special placeholder solution for Exocad, where we offer 5 different offsets from wide to super tight. And I will show you later on where you can find these different offsets and how you can handle these different offsets. But we can change the size, the friction of this part that takes the DIM analog. And it's the same if we have the situation with the multi-plus abutment, or if we have this situation with platform switch or platform match DIM analogs. So we can adjust the fitting in our system. So now we go to the integration. Oh no, sorry. We go to the download of the material libraries. And so to go to the download of the material libraries, we have to go to our website. So we have available material libraries for production on abutment level. Abutment level means that the production, the crown production, will be in this area. This is abutment level. We have material libraries for the multi-plus system in connection with the model printing, and also for the tie base in connection with the model printing. For the one care package system, this is will follow the one abutment one time situation. So this abutment will be placed directly in the mouth and will be scanned in the patient's mouth. And so we have here no solution to print a model because we do not need a model. And we provide our material libraries for the 3Shape system, for the Exocad system, and for the dental system. So as I told you before, we will find this on our website. So when we go to our website, we have to navigate to implantology solutions. So now we click implantology solutions, then we come to prosthetics, and this is a very important point for us, or this is a very important crossway, because you can turn into the on this point you can already turn into the wrong direction, because if you are going to use platform switch components, you have to make sure that you download platform switch design libraries. If you're working with the S implant with the platform match, you have to make sure that you download the platform match libraries. Otherwise, if you downloaded the wrong libraries and you come, for example, you downloaded platform switch, but you want to work with platform match, you can't. The system doesn't run it. It won't work. So make sure that you choose here the right way. After confirming, you can come. You will be guided to the point of CAD CAM prosthesis. Click here on Find Out More. Then you come to the next site, Download Material Libraries. Just a few clicks until you find this form. Very important is for the download that you fill this form completely with all informations, and make sure that you set both hooks, and then you will confirm this. Otherwise, if you only set one hook, you will receive an information that you did your download, or that you did that you order a download, but you won't. It won't work. You won't receive the material libraries. Only this information on the next site, but you won't receive the email. So here, this is still on our website, the information that you ordered a download, and then next you turn to your email program, open up your email program, and you get an email with the information that you can download your libraries. So you will be asked if you would like to download the libraries. Yes, of course I will. You click confirm, and you will receive an additional email. And in this email, you're directly in the download area. So I will give you the example with the adhesive abutment for platform switch, the tie base. So if we would scroll here, we will find Exocad, and below Exocad, we also will find dental wings, but I will demonstrate with the download for the 3Shape system, the tie base. So just click here and you will get the next information from your Internet Explorer that will show you your downloads. I told you it's always what we are working with are STLs. STLs are the base datas. On 3Shape, you will do you will download DMEs. A DME is always an STL base with additional informations. So you can open or save. What I do is I'm creating a folder on my desktop and put my libraries in the desktop for the system integration. So I'm just saving my downloads. And now we come to the integration of the material libraries. We start with 3Shape. So for this, I'm doing a live demonstration. So I have to leave my presentation. Okay. So now we are going to download. We downloaded already. Sorry. So here I have my downloaded DME for 3Shape. And yeah, to import it, I have to open my 3Shape control panel with a double click. The procedure in 3Shape is very, very easy. It's just a few clicks. It's a little bit more difficult in Exocad. So now we are in the control panel, and here is our part for the import and the export. Just click on import. Now, yeah, you will be asked if you want to import materials. Yes, of course, we want to import. Just click here. And now here I find already automatically my DME, my downloaded DME. Here you can see this is 3Shape specific. Now just do a double click. That's all. Takes a little bit of time. And just confirm import. And it should be done in a few seconds. Okay, materials have been imported successfully. So in 3Shape, you see it's just a few clicks, everything works automatically. I'm just confirming here. And now I have to go back. There's one thing I just want to talk about it before before I will leave the 3Shape control panel. I told you that I can change the offset for the DIM analog in 3Shape, and we have a different solution for Exocad. So the 3Shape solution, if you want to change the offset, you go here on digital model, and here you can find your printers, the model printers, and here you can, in this area, sorry, it's in this area, you can adjust the offset or the friction of your placeholders for the DIM analog. This just was site information. So I want to go back. So everything is imported. We have to confirm everything is imported into 3Shape. And now is the time we can start working with our 3Shape system now. You will find, sorry, You will find this information. I'm too far. So, okay. So now our data are integrated into 3Shape, and you will find your information in your in your job sheet. When you're clicking your desired construction, you will find your system. It's a BEGO Implant System, Klebebasis. It means adhesive base, and this is for the PS platform switch, TIB, tie base, the 4.1. And this is the ref number with a hex, rotation protection, gingiva height 0. This is the right one for a single anterior. So, and now we will come to the integration to the integration of materials into Exocad, and this is a little bit more complicated. So I also have to do a live demonstration. I have to leave the presentation. So for Exocad users, I have here 2 different Exocad icons. This is the generic Exocad version. This is the BEGO reseller Exocad version. There are also reseller Exocad versions for Ammon-Gilbach, Zircon-Zahn, and several other systems that are based on Exocad. So there's sometimes small differences, but the way is always the same. You take your mouse and click with the right mouse button. Important is the right mouse button on your icon, and click with the left mouse button opening data path. Here you can see now these are the passes that I will go, and we have to find the Dental CAD app. So we go to the Dental CAD app, open this with a double click with the left mouse, and now we come to the library section. So we go to the libraries because we want to import or implement material libraries. And so we open the library section with a double click. And now we are in the library section. Herein are all digitalized informations stored that we need in our system. So we are going to import our libraries into the implant library, but also into the model creator, because we want to be able to print models in the end. So I start with the implant, and here I have already prepared my downloaded material libraries. And in this file are all the informations that I have to integrate in my system, but I have to split it. So I have to unpack or to open my folder. Sorry. Okay. I was a little bit too fast. Sorry, I have to start again. Okay. So in this folder, there's one information missing. Just 1 second. There's just one library is missing. But I will organize them. It will take me a few seconds. I'm sorry for this. Okay. Yeah, I have also my libraries inside. Okay. So this is how we get it. this is how we unpack it. So, and here I have my libraries, and I will store this information. This is good. Okay. Just checking. Okay. This I will integrate, and now we can start again. I'm sorry, I have a technical problem. Okay. And I will continue soon. Okay, so starting again, sorry, there was one folder missing, and this morning it was still there, but I don't know how it disappeared. So starting with the right mouse button, opening data path, going to the dental CAD, opening the dental CAD app, going to the libraries, opening the implant library, and here are already some implant information, some libraries integrated. And now we integrate our okay, so everything is fine. So here you can see this is the file with the informations about the about the implant, and this folder will be integrated into our implant library. So copy and paste. So this is the information about the platform switch tie base, and this is the information, and here you can see the MC. The MC is for model creator, and so we have to give the information into the model creator. We open the model creator with a double click, and we want to import into the model creator implant information. That's why we open implants. Here you also see the informations, and in this information is always the placeholder for the DIM analog that we can print into the into our printed model. Now I have to go to the model creator library, and I will open it. You can't import the complete folder because I was talking about the different offsets, and we have here 5 different offsets, starting with the standard offset. And in my opinion, the DIM analog is a little bit too loose. It's rocking a little bit, and I will start with the offset 0.04. It's a little bit tighter, and it will create you a nice friction of the DIM analog in your model. But you can't even copy this folder because you have to open the folder. And behind here are my STL files. And so you have to import this folder with a copy and paste. So here it appears. So very important, please keep in mind, do not take the complete folder, not even the offset folder. So please open the offset folder, and this folder can be integrated, and then it will work very fine. Okay, and now we are finished with the Exocad implementation or the integration. Even when it was starting with some some technical problems or some appeared data files, but that worked out fine. And now I will continue with my presentation. Okay, so we have integrated already successful our material libraries into Exocad. And when we start working with Exocad, we can just say, or we can just give the information, I want to do an anatomic crown or an offset coping or what else. And here I give the information, I want to do it with an implant, or I want to create an abutment or a screw retained crown bridge, whatever. You give the information here. This is still your working sheet, but the information is for the implant system is only available from the point that you when you do your matching process, when you are matching the when you are going to match the material library into your 3D imported model. So from here you can choose your desired product, like in this case it's the Implant Systems adhesive base PSTI. We have here platform switch. That's an important information, but this information is also here. Platform switch, tie base, the lot number, and if you would open this menu, you will get some additional information about what you have chosen. So, and from here you can start now working with your crown design. And at the end of the crown design, the system will ask you, do you want to print a model? And you confirm this with yes, and then you can click through your model construction. Okay, so this was about working with the material libraries, how it works with the scan, with the intraoral scan. But now I want to come to the physical DIM analog, just to show you how it's looking and how we can handle it. So we have here two different situations, two different model situations with these printed placeholders. And you can see here already, this is the DIM analog with the cone for the multi-unit system, and this is the DIM analog for the platform switch. And it's looking almost similar to the platform match, but we have different DIM analogs. But the fitting, this part of the fitting, is always the same. So make sure that you insert the DIM analog under attention of the rotation protection. You can see this for the 3 rotation protections. You can easily insert a multi-unit DIM analog by hand, turn your model and screw it from the bottom of the model. It's a little bit more complicated if you're using the platform switch or the platform match DIM analog, because it's small and sometimes it's lying deep in the model. But what you can do is you can take an insertion post. Here in my case, I just took an impression post, and just take the impression post as a pickup for my DIM analog, and now I can insert it with an insertion or inserting support, and bring it in the right position and insert it until I can screw it from the bottom of the model. So, and at the end of my presentation, I want to come to a part that's really important for me to get perfect results in the gingiva management. So you should be able to open a gingiva in the right way, in a physical way, and so you can transmit it into your digital workflow. So starting with the gingiva management preparation of the exit profile, the design of the exit profile or the emergence profile should be set in the cooperation with the dentist. So for optimal results, you need the information from your dentist about the condition of the soft tissues. So there's a tissue measuring indicated. It's called resilience measuring, and to say is there's no universal solution to form the emergence profile. For thin gingiva types, is a concave design indicated. For thick gingiva types, you can also do a convex exit design, but in the most cases we have the concave exit design. So the information about the tissue condition should be transmitted by the dentist. So what you see here is a case with two implants, and here is a veneer. Here this is prepared for a crown, and you see we have a completely round exit profile. And I did some markings on my model just to see how long is the neighbor tooth, and you can see it's until here. So I have to open a large amount. Next is, this is totally round, this is not round. And you find the best way to detect exit profiles is to take a model and cut horizontal the teeth, and then you see we have for each tooth a different exit profile. And very important is the papilla, to keep the papilla. That's what the surgeon tries hardly to keep. We can destroy in a short time if we compress the papilla. So we have to make sure that we keep enough place interdental, not too much and not too less, in the right amount. And here you can see I already did some drawings on my model, how and in which way I will open, and you see this is not a round exit. This is an anatomical exit, and still beware here my papillas. So what you see here, it's already opened, and important is that the first third, the first 33% of the exit should be straight, should be not opened. Leave it like it is from the impression post. Start straight, and then you go into the concurve of your exit profile forming. Here you can already see this is opened a little bit more. This is only a demonstration model. Here's only one a crown, one PFM solution. The other ones are only temporary materials printed just to check fittings. It's not polished, but the finished result is this. So keep in mind, this is not polished. It's only printed just to teach about keeping your papillas, getting your perfect exit profile. And you can see I have still my papillas and even a small nice triangle. And to get these results, you should open some plaster models, and then you can transmit it into your technical or your digital technique work. So now I'm at the end of my presentation. I hope it was a good information, raw information for you. And if you have further questions, you can contact me on my email address. Now I will return. to Marcio and to listen if we got some questions.
Okay, thank you very much, Stefan, for the very nice presentation. Just before we start the question and answer session, I would once again bring just to inform you about the next sessions of this webinar series. We have next Tuesday at 11 a.m. in Central Europe time. We're gonna have Dr. Oriol Cantor from Spain. He's gonna also speak about CAD/CAM, important points to keep in mind. But another approach, as Stefan made today, would be a more clinical approach. Today we come from the dental laboratory approach. We're gonna have then 4th of May, Dr. Juraj Tucin from Croatia talking about implant prosthetic therapy, planned for yesterday for tomorrow. And the last webinar for the series would be at the 6th of May, Wednesday, from 2 to 3 p.m. Central Europe time with Dr. Erham Konjeluglu from Turkey talking about digital approach, impairing implantary, pink and white aesthetics, immediate definitive custom abutments. We have our education program for the second semester of 2020. After the final of the corona crisis, we have a course with Dr. Gerd Körner from Germany in Zagreb, Croatia. The topic will be from periodontal downs to aesthetic hives on implants. Then in December, in our headquarters in Bremen, Dr. Kleanthis Manolakis from Greece talking about digital workflow, a course with a hands-on. We have our open days in November and December. The headquarters in Bremen with discussions with our team, for example, with Stefan, company tour. So this is a very nice program also with visits to the Christmas market. So this is our program for the second semester. Again, we have the campaign Help Against the Corona, We Care. In our webpage, we have STL data free to download. So you, in your clinic, in your dental lab, can produce several different tools to prevention against the corona, like the modular frame for a face shield, breathing mask brackets, breathing mask frames, door hook, door opener, door handle attachment, hand protection. So please feel free to go to our website to make this download. This is an example, a photo courtesy of the colleague Ivor Galic from Croatia that printed a glass framework in his dental lab. We have one question here, Stefan.
Yes.
Is there a library for custom abutment? And is there another process for custom abutment?
What do you mean with custom abutment? Custom abutment is an abutment that will be produced on implant level, right?
Maybe the colleague can tell a little more. I don't know if he's talking about the one piece abutment, the ones that we produce in BEGO Medical.
I think he's talking about the one piece abutment, and yes, indeed, you can use. No, we have no libraries for in-house production for that, but you have the possibility to do the custom abutment in our production center in Bremen. So there are also libraries, but they had to be downloaded by BEGO Medical. But we do not provide the solution to produce your custom abutments in one piece on implant level.
I think, which scan body do we have to use?
for what?
Yeah, the colleague did not said here, but yeah, maybe
Okay.
we are talking about the scan body to custom abutment. Now he's coming here with for
Okay,
custom abutment.
to custom abutment.
I can
If
put
you
back
want,
your presentation.
Pardon?
Then you can show the custom. Maybe you can show the scan bodies
No.
from.
But so if you want to produce a custom abutment, a one-piece abutment on implant level, you can't produce it decentral in your own lab. You can only produce it central in a milling center, and the milling center has to provide the data files and also the scan bodies. So if you would use our scan body, you can use our scan body and work with our scan body with our central production. But if I got the question right, the participant was asking if he can produce in his own lab on implant level.
Probably that's what I got. That's what I've got too. Yeah, that's probably what I could understand from here.
That's not possible. You can produce on implant level single crowns. It's not a real implant level production because we have this pre-milled blanks for that. But the topic of today was only about producing on abutment level, and the difference is to produce on implant level. And for implant level, we do not provide our connection piece geometries.
Yeah, maybe if you allow me to resume, is what Stefan said. In our web page, the colleagues can make the downloads of the geometry of our tie-based abutment, the multi-unit abutment, and the OCP abutment. For this, we have the scan bodies. Then, if the dentist or the dental technician wants to produce a one-piece abutment, so a connection direct to the implant, the scan body to be used is the same. We provide the scan bodies, but the production is made in our headquarters in Bremen.
That's what I wanted to say.
Exactly, and what Stefan said, to make a one-piece abutment in a decentralized way, the solution would be the use of the scan body and then the pre-mill blanks. This is also possible. The original.
It's only a solution for a single crown. So
yes, yeah. Okay, I hope we answered the question. Maybe the colleague is Dr. Murat, so you can send us a feedback if we answer your question. Then we have another zirconia custom abutment cemented on a standard tie base. I think that's what he means. This was another colleague saying, yeah, can be, Stefan, yeah, but zirconia custom abutment cemented on a standard tie base, okay. This can be made.
You know, the wording is always a little bit confusing because what is a custom abutment? In my case, or in how I understand, a custom abutment is a one piece. So that means the whole abutment is one piece, made, for example, from in titanium. Yeah. What we have been talking about today are duo abutments. So I have the connection piece in the perfect material with a perfect industrial fitting in titanium. Yeah, this is a confectionated piece, and we will do an adhesive connection with the second part for the exit profile. So what I mean is, we have one abutment in titanium. This is the tie base, and over that I put, how can I explain it? The second part of the abutment. The second part of the abutment will be milled in zirconia. and then we do an adhesive connection between those.
Thank you. You received some compliments I would like to share with you, Stefan, from Dr. Helen van der Kram, from Dr. Vlad Boydian, our colleague, our friend, distribution partner, Mr. Virendra Shukla, said that unfortunately he could not attend the entire presentation. Virendra, you can have the recording of the presentation afterwards. We will be glad to send to you. Our colleague from the international sales, Ralph Lexish, thanking a lot for the efforts. Dr. Shaham, our friend from Iran. Hello, Dr. Shaham. Nice and interesting webinar. Thanks a lot. Kamram, our distribution partner in Iran, also send you a very nice webinar. So thanks to you, Stefan. Sharif Mahmoud, thank you so much for the amazing webinar. Now comes a question. Can you do multi-unit abutments with long span bridge using zirconia framework? Multi-unit and zirconia framework.
Yes, you can, but not official. So we have a solution. We have a beta solution. So it's the same technique like the tie-based technique. You use an abutment. It's called, I think it's a titanium abutment.
Titanium abutment for multiplus.
Titanium for multiplus. What we did is we digitalized this titanium abutment, and we use it as a placeholder. So it has the same use like a confectionated tie base, but it's not yet a validated process. So that's the reason why we have it only for the multiplus as a beta tester version. So we can do it, and the procedure is the same like the procedure in with a dual abutment or with a dual abutment crown. So you do an adhesive connection between the zirconia construction and the tie base. So we have a solution, but the solution is not official. It's a beta tester solution. So
yeah, sorry, can continue, please.
For testing, I can provide you the data files and give you some pictures how you can receive your result, but it's not an official version. That's important. That you have to keep in mind.
Yeah, that's what I would say. The question comes from Dr. Firdaus Hanapia from Malaysia, which including said excellent presentation. Love from Malaysia. Thank you very much. So Stefan, so you would be able to send Dr. Firdaus
yes, of course.
So please, please, Dr. Firdaus, send us your. You can send in the question box. Please send your email address, and I forward this to Mr. Stefan Kautz, please.
And so this is funny because from Malaysia. So I had today a discussion with a guy from Taiwan, Taipei, and he was asking for the same. So
yeah, we receive now. We receive from Greece, from other countries. We receive this requirement now.
Yeah, it is working. You know,
it's working. Yeah.
It is working, and you can receive or produce nice results. But please keep in mind, it's not official. It's still a technical tester version.
Yes, I received the email already here, and I will forward this to you, Stefan.
Perfect.
Where to download the library? This is an interesting question because the topic is interesting. Where to download the library from pre-mill blanks, Amangueba, if we need it for Ceramill system. Can you tell a little bit about how it works with the pre-mill blanks and the Ceramill, please, Stefan?
Okay, so for the Ceramill blanks, you're working with our scan bodies. And you're just doing your crown construction, and you generate an STL file when you're constructing a crown. And this STL file will be sent to your Prezi mill, for example, the Ammann-Gierbach milling unit. And that is the point when you should be asked which kind of crown or which kind of blank are you going to use for this production. So you will get from Ammann-Gierbach the material libraries. I think you have to contact Ammann-Gierbach and ask them if they have a download or if they send it to you via email, or if it is already integrated in your Ammann-Gierbach system. So what we are just doing with our scan body is to show where is the position, but the milling strategies and how to place it inside the milling or inside the blank, or how to place the blank inside the blank holder. This is based on Ammann-Gierbach data. So just contact your Ammann-Gierbach supporter for that.
Okay. Also from Dr. On Take sorry to the pronunciation. Also I also wrote your email, Dr. On, and we also send you we inform Mr. Kautz about the multi-plus abutments. Dr. Carlos Nunez, probably from Spain, also send thanks a lot to you, Stefan. And I believe in this moment, maybe Stefan, only you can put your email address back again. I'm gonna give you the moderation.
It must be still here on the screen. Can you?
Okay. Now, probably you can put now.
So can you see it?
I'm not seeing yet.
Moment. But now.
Yes. So this is okay. So this is
it was still available for me, but not for the participants. So sorry.
Okay. No, that's for the participants now. Yeah, I believe we receive nice feedbacks from the colleagues. Stefan, once again, thank you for your time. Thank you for being with us today. I know that you made one today already for the German market, so it's your second presentation today. So thank you very much for your time.
Yeah, thank you for your participants, and special thanks to you, Marcio, to support me.
That's a pleasure. And Angelica is our
and also special thanks to Angelica, definitely.
Yeah, that's definitely Angelica. You receive one more, Dr. Jafari. Thanks a lot for the lecture. Yeah, so hope to see you next week in the next session. Yeah, and Stefan, also thank you very much, and see you everybody soon. So yeah, this time finishing the session today.
Yes, Marcio, hope to see you soon. Yeah, stay as you are, keep healthy, and to all the participants, keep healthy and enjoy your time.
Thank you very much.
Thank you. Bye.
Bye.